Spark plugs, one of the most important things for your engine. Make sure it's going to stay running and producing enough power. So every 100 hour, every annual, you're going to pull the spark plugs. You're going to obviously look at each one. You're going to do an evaluation because you want to see how healthy it is, the color. Here's one that's been sandblasted. It's a little bit lighter in color. It's a duller color right there. That's actually a good spark plug. That has the right combustion, but you also want to look down around inside the insulator. You're looking for lead buildup, balls of lead. If it looks like there's a sandbox in there, somebody hasn't been leaning the engine out enough. If there's a pool of oil all the way around there, you've got issues with the rings not controlling oil, how much gets through under the cylinder walls and all that kind of stuff. They show you a lot about the health of the engine. It's going to be showing you probably the next most important one to the oil filter getting cut open and inspected, and right up there with taking a good look at your compressions, because your static compressions really aren't so much about how much power the engine produces. They're more about, are your rings broken, are your valves leaking, are the valve seats cracked, or is there a crack in the cylinder? And that's what the static compression is all about. So first thing you're going to do after you do an evaluation, especially on your bottom plugs, you really want to take a good look, see if there's any oil or lead buildup or anything like that. And the next step is the cleaner, the blast cleaner. There's a variety of models, so I can't show you every one, but I'll show you how this one works. And this, just as I said, happens to be the one my shop has. It's a good idea to wear safety glasses while you work with this, because sand will shoot out of here around the spark plug and it can get in your eye. But you literally stick it in, and then the air cleaner, this is going to blast any loose sand off of it. That you can do quick, but the reason you're turning it around is the jet is only aimed really at one side, so by spinning it around you change where the jet hits. And that gives you a good clean. Obviously, as I said, when you're cleaning, take a flashlight, look down inside, see what you get for lead down around the base of the insulator, inside the shield. No, that's not showing up at all. Alright, let's try that. Alright, there you go. Now you can see it better. You can see down around the insulator on the inside. If there's a lead, it'll be like a white ring, or sometimes it'll be like balls, little lead balls down inside of there. You want to get all of those out. And if they're still in there, the next thing you need to do is nice pick. This is, I believe, from Harbor Freight, and dig them out as much as you can. If they're more embedded than that, we'll go over to this. There's a variety of tools. Here's like an engraver tool that has a little fork thing on the end, and that you would stick down inside the spark plug, and it will vibrate and it will help you dig it out. This is a bigger one, has two forks like that. You can just stick the spark plug right down in with the forks down inside of it. If I get that far here. And that will work any lead loose that you might have. Now this is almost clean as a whistle, so I'm not too worried. I was just demonstrating. And the next step after you have cleaned all of your spark plugs and made sure there's no lead or anything inside of them is the gapping, which there are a variety of tools. This is just what my shop has. I've worked at other shops that even had tools that I thought were better, they were faster. This one works. Simply thread the plug in. You want to line it up so the electrodes are up and down. We have the gapping tool. This is an actual, I believe, Champion part. Might even have come with this tool. And what you're looking to do is you're looking to have those tips actually in between the electrode and the electrodes in the center conductor on the spark plug, so that it's like that. And then the whole point of what we're doing, so we got it like it's actually wedged in there, but notice it pulls out very easily. However, with it inserted like that, we're now going to screw the screw down in onto the electrode until we can't pull it out. Now don't go further, you're going to break the center electrode if you do. Just go down, you'll feel tension, give this a little tug, and then the whole point is rotate it around. Do the same thing to the other side. And you'll learn the feel of it. Just don't go overboard with cranking down on this hand screw right here on the top. And when it can't pull out, that's right, back it off. That's the minimum dimension. It's going to slightly bounce back from that, and that'll be perfectly set. Go ahead and remove the spark plug. And then your last check on this stage is, this is a go, no-go gauge. This is also, I believe, from Champion. And as it says, if the plug enters the hole, scrap the plug. Now the back side of this, it's chamfered. This isn't Champion. This is ATS erosion gauge. The whole point is, if you can stick both electrodes into that hole, they're too eroded. This center electrode is going to go more and more elliptical as it wears. These electrodes from the side, they're going to get thinner as they go, because every time a spark jumps, a couple molecules of metal burn away, go with it, whatever's happening. The metal is constantly eroding away with every spark, which is why a spark plug goes bad just from wear, even if nothing else goes wrong with it. Now, if you drop a plug, throw it away. If that center electrode's cracked, it's going to start arcing into the shell. And I have another spark plug I'll show you where it literally blew in half and the center electrode blew right out of the tip. And probably it started by somebody dropping it and cracking the electrode. Your next step is going to be to clean these threads off so they don't have all this grit in them. Wire wheel works good. I've seen people do this also with a wire brush. It just takes longer. Don't touch these electrodes with the wire brush. Don't drop it. You always want to have the tool rest here in close so the plug can get sucked into the wheel, because that could destroy it. Your next test, of course, is going to be spark test under pressure. And you just got to screw this down. It doesn't have to be tight. You just need it to hold air pressure, but it doesn't have to be like you put it in with a torque wrench. That'll do it. Stick your wire in the top of the plug, like so. And then what you want to be doing, get this lined up right here. Inside that area in the mirror, you can actually see into your spark plug. It's reflecting up. Turn up your pressure. Yep. So you see it's a nice blue spark, nice and hot. That's what you want to see. A reddish spark, a sputtering spark, those are things that are not good, and they indicate that you may have issues inside your spark plug, maybe with it arcing inside between through the ceramic, maybe probably a crack in the ceramic to the outer shell of the spark plug. That's bad. Obviously, turn your air pressure back down. And then take your plug back out and do the next one. So you have all of them tested to be sure that they are a good plug. And after you have gone ahead and cleaned your threads off, you've tested for spark. Last two steps. Now I have old collars, old gaskets, spark plug gaskets here. We just replaced them. Some places I've worked have been cheap about it, and instead of putting a new one on every time, flight schools will do this quite often. You take all of these, you hang them on a wire coat hanger, and you hit them with your acetylene torch, like you use for soldering pipes or whatever, until they're like cherry red, and then you quench them in water, and they will be re-annealed to the correct hardness for reuse. And you can do that as many times as you want with them, from what I understand. I don't know though for a fact, I just know that's what I was told at places I worked, that they did that. Like I said, we make money off of selling parts, so everyone gets a new gasket. The other thing it gets is some anti-seize, just so that the threads don't gall up into the helicoil that is in the aluminum head of the cylinder head. And literally you want to take even smaller brush than this if you get one. Don't go at the side, because the last thing you want to have happen is any of this anti-seize get into that spark plug gap, because it will short the plug out. And you're literally just looking to put a dot like that on your threads. You don't want any more than that. That's all you need. If you do more than that, it's just, as you know, anti-seize will go everywhere and cover everything and obliterate the whole world. If you go anymore, like as you see, I just touched the bottle and it's already on my fingers, and if I don't quickly wipe this off, I'm going to be completely copper covered in about an hour, maybe less, because that's just the way this stuff works. So a tiny dot, all you need. Don't get in your electrode. New spark plug gasket, and your plugs are done. And I know I've showed this before. This is a spark plug. This is what happens if you crack that center electrode and it starts arcing to the shield, the outside of the spark plug. That's what this plug looked like when it was last put in. Notice there's no there in the middle. Center electrode is gone. That's the way I found it. Center electrode's gone out of there as well. And this is how it broke when we tried to unscrew everything to get this off the end of the wire, because this was just laying up there in the cylinder, and every time this cylinder fired, there would have been a jet of burning plasma basically shooting out of this hole from inside the cylinder, a jet of fire, which luckily didn't damage anything or hurt anything or burn the cowling or anything like that. And this was an aircraft that was just ferried in from Africa to Maine when I found it. So who knows how many hours flying over the ocean, one cylinder on a twin engine, luckily, a 402, was firing like that with obviously a horrible compression. But it survived. But this most likely, notice there's a section of ceramic missing here. This most likely happened from somebody dropping it or otherwise damaging it before it was installed in the first place. Last step whenever you're doing spark plugs is you have to rotate them, because electricity works with positives and negatives, and the way a magneto works with a magnet exciting a field inside of a coil, that coil holding the charge, then releasing it with the points in the condenser and all that fun stuff that you learned in school, or you will learn in school if you haven't yet, or if you've forgotten it entirely. The big thing to remember is magnets have positives and negatives. Positives and negatives, of course, induce a magnetic field in different directions. You know, technically a magneto, you could call it AC. It's just the way the distributor works and all that, that one plug ends up firing from the center to the outside every time. The next plug fires from the outside to the center every time, because the way negative and positive both will create a spark. Just like lightning, even though we always think of it as going from the cloud to the ground, can just as much go from the ground to the cloud. It's just the way charges work, and positive and negative. So these plugs, some go one way, some go the other way. The engine doesn't care. It's a spark. Spark lights the gas. Boom. Engine goes. That's all we care about. But what we do have to think about is the way that they erode. As I said, every time a spark jumps, a couple molecules of metal go with it. I don't know that I've ever seen that written anywhere, but that's what I understand is happening with the arc that's happening, and the temperature of the arc and all those kind of things. And so the metal is going from one side to the other. And so we want to rotate them so that they erode evenly on both sides, and we don't end up with the outside shell contacts being extremely thin while the center electrode barely wears. So to do that, look up a chart for it. In this case, Continental has a chart just for the IO 550 that tells you where to put them. But basically what you're going to do is you're going to take the plug from, let's say, top of number 1, and the top of number 1 will go to the bottom of number 6, and the bottom of number 6 will go to the top of number 1. And now we just flipped the direction the sparks are going to be jumping across the electrode to the outer shell. That's all you're doing, but that's the last step before obviously you install them, and always use a torque wrench when you put them in. And the reason for using the torque wrench is that the cylinder head is aluminum, this is steel, and what they do is there's a helicoil threaded into that aluminum in the cylinder head, and if you go nutso with the torque, you're going to strip the cylinder head, and now that whole cylinder's got to come off, and now you're talking a couple $100 and downtime, and everybody's unhappy. And you could have saved it just by doing a torque wrench. So use the torque wrench. And of course the last step with installing your spark plugs is putting the harness on. And there's a B-nut that you have to secure down onto the spark plug. And let's say you're working on an aircraft that you cannot get the torque wrench in there. The other easy thing, now this is the Lycoming setup. Normally we'll have a small hex and a large hex on the B-nut and the actual end of the lead. Continentals, you might need to use a wrench because it's shaped differently. Use a stubby wrench, because if you go to town on these are just aluminum and you will shatter them. You'll destroy and cause a lot of trouble for yourself. But if you use a stubby wrench, you will not over torque it, no matter what. Now this I could get a regular crow's foot regular torque wrench on, just demonstrating this for because the issue you're going to deal with. And once again, before you cowl up your engine, you're going to check all your B-nuts, see if they're tight. You should not be able to turn them by hand. You're going to check your fuel injector line nozzles as well. Make sure those B-nuts are tight. Anything else you may have worked on, Obviously, heater muff, that's something that comes apart for an inspection. You want to make sure that's back together. Your air filter housing, make sure that's on, and there's actually an air filter inside of there. It's sticky. Yep. And oil filter, and that there is safety wire on it. Just a quick last minute check. And the big thing is no tools. I've seen rulers left in here, I've seen pliers, I've seen wrenches, and gloves. Gloves will be a real issue because you'll end up with one side of your engine not cooling correctly. And if you usually I've seen owners come back and say, hey, one side is reading a lot hotter than the other, can you check it out? And yep, somebody left a pair of gloves in there in the wintertime. Don't do that. Obviously look for rags, gloves, anything that might have fallen down inside, anything that could be loose. You're the last line of safety for what's inside the cowling, especially what cannot be seen from the outside of the cowling by looking through the oil door or through the inlet where the air comes in. In some aircraft, that's pretty tiny. And then obviously, every time before you run an engine, look for oil on the dipstick. You don't want to be that guy. It's a real bad day. Often a career ender.